Well, welcome back, and I'm sure you noticed you saw a very interesting portrayal of how to change decimals that terminate and repeating decimals into the fractions they came from. I'm going to show you even a little bit of more of a shortcut that I allow people to use because they're the type of decimals we encounter all the time, but I'll get to that in a couple seconds. So let me share the screen again, get the sheet up here I want, and away we go. All right, let's take a look at these fractions. Now you remember, I'm sure, how to change fractions into decimals. You divide the bottom into the top. So that's a very simple process. So pick up your phone or your calculator, all right? And let's divide these out quickly together. On your calculator, take 7, and let me turn the calculator on, that probably would help. 7 divided by 8, and of course that gives you 0.875, right? A nice terminating decimal, all right? 0.875. Should put a 0 out front. 8/15, of course, you know you divide 15 into 8, or on your calculator, the 8 goes in first, obviously, right? So 8 divided by 15 yields for us 0.53 with a bar over the 3. The 3's repeat forever. So that's a nice repeater. 2 and 15/11. Well, just remember you can put the 2 down there, right? Not 15/11, 5/11, sorry. Now you divide 5 by 11. So take 5 divided by 11. And when you do, you get 4, 5, 4, 5, 4, 5, 4, 5 forever. So it's 0.45 bar, okay? 6/7, you may remember this from middle school and high school, that the 7ths repeat in units of 6 digits. So this will be -4 point, and you take 6 and divide it by 7. And when you do, you get 0.857142. Then it starts over again, 857,412. On your phone, you can tell that better because it shows you more digits. Remember, you turn your phone sideways to make it a scientific calculator. This whole unit right here, okay, repeats. All right, 39 1/11. All right, so you put down your 237, and you take 39 and divide it by 111. And when you do, you get 0.351351. So it's a repeater like so. And of course, 7/18, all right? You put down the 905, you hit 7 divided by 18. And when you do, you get all 8s after a 3. So 3, 8, 8, 8, 8, 8, 8, 8, keeps on going. Rounds to a 9 on your calculator, but it is repeating 8s. Okay, so you recall that. How do we go back the other way? Well, you know what? I'm not even going to make you learn what you saw in the video you just watched before this. I thought it'd be of interest to you to watch that video. I thought it's very well explained, and I thought that maybe we should come up with a simple method. It's very common for us to have decimals that start right out at the decimal point and start repeating, like the 2 I'm circling right now. Now, you know what? The Kelly's-Teeter method, I didn't invent this, but I call it the Kelly's-Teeter method. And you can use the Kelly's-Teeter method to convert these back. Are you ready for this? It's this simple. You take, how many digits are repeating in 4545454545? 2, right? So you take your 2 digits, 45, and you put it over the same number of 9s, 99. You know what? 45 over 99, if you can reduce that, it reduces to 5/11. Guess what? for the 237.351, this only works now when the decimal begins to repeat right at the decimal point. You can simply just take 351 and put it over 3 nines. And guess what? If you reduce 351 over 999, it'll reduce to 39 over 111. It turns out that 9 goes into both of those numbers, okay? And it reduces very nicely to 39 over 111. I will never make you reduce your fractions once you convert them either, okay? So now, with that being said, let's go down and practice some of these, all right? Some more of them, all right? So let's go here. The 0.78 doesn't have a bar in it, so you just put it over its place value, 78 over 100, and then you reduce it, 39/50ths, right? But look at this one, 0.9 bar, 1 digit, right? The 9s are repeating. I put it over how many 9s? 1. Wait a minute. Does 0.9 bar equal the value of 1? Turns out it does. Turns out it does. Those repeating 9s do a very weird thing. You can mathematically prove, and I'm not going to bother doing that now, that 0.9 bar is exactly the same mathematical value as 1. Imagine that, right? Okay, 0.324 repeating. You simply take 324 and stick it over 3 nines. And you can leave it like that. You don't even have to reduce it. I'm not going to require you to reduce it on the test. Just remember, that is the correct answer. And, okay, so it's very, very simple process. And you can simply write the Kelly's cheater method, and I'll accept your answer. Okay, let's go on. 0.9825 as a repeater is just 9825 over 4 nines. Now you cannot do that Kelly's cheater method on this problem because it doesn't begin repeating right at the decimal point, right? The Kelly's cheater method only works on decimals that are right next to the decimal point when their repetition begins, okay? So, and all I'm going to ask you for is the Kelly's cheater method. I thought it would be good for you to refresh your memory as to how mathematicians usually change repeaters that are of any shape or form. And you got to see that in the last video, which I asked you to watch. But I'm only going to ask you for Kelly's cheater method type ones, okay? Because you run into them all the time. So if you remember that, if the repeating starts right at the decimal point, just remember, put the number of digits down that are actually repeating and stick it over that number of 9s, and you'll have your answer. You don't even have to worry about doing a massive conversion. All right, I would like you to go to group work 15, which was attached, okay? So I want you to take a look at group work 15, the front of it. A lot of the sheet has been crossed out, okay? Now, the fractions up at the top, you know how to convert those into the decimals they came from. You divide the bottom into the top. I'm not even going to worry about doing those with you right now. What I am more worried about is the second group, starting with problem 7. 9875, 0.9875, if you want to convert that to the fraction it came from, there's no bar on it, right? Therefore, what do you have to do? All you have to do is put it over its place value. And of course, its place value is 10,000, okay? And you reduce that, you'll have the answer to that. But you don't even have to reduce it. That is the correct answer. For number 8, 0.25 bar, you simply put what? 25 over 99. All right? For 11.5 bar, you put the whole number down. How many digits are repeating? Just 1, the 5. You stick it over 9. 11 and 5/9 is the fraction or rational number that 11.5 bar came from. This one, you put down your negative 14. There's 3 and 6 repeating together in a group. So you put 36 over 99. And of course, that reduces to 4/11. All right, but you don't even have to reduce it. Just give me that answer. I am pleased. Okay, the next one, 351 over 99. Okay, I believe this comes out 17/33 when it's reduced. Now you got to be careful on number 12. Notice the repetition does include the 0. So in other words, when this 11.027 with the bar over the 0, 2, and 7 repeats, okay, it repeats 027, 027, 027, 027 forever, okay? So you need to put the 027 over 3 nines, okay? All right, so make sure you do that, okay? All right, for 13, okay, all you do is put the whole number 2 down and put 9675 over 4 nines. That's all you need to do, and I am thrilled with that. So just do that, and you're in good shape.